Hey Al, how's it going? So in this one, what I wanted to show you was that even though our scores have been improving for our prediction model, we're actually losing a lot of data from the rudimentary filtering that we're doing. So I put in a print statement here after we just select everything from the database, and we're getting 423,000 athletes. And then when we do just our drop NA function here, it's going down to 4,800, so about a 99% decrease. And then when we're filtering outliers further, we're only getting 1,200 athletes. So we're really losing a lot of data throughout that whole process. So there is a better way of doing this, and that's what I want to show you in this one. There's a process that you can use called imputing the data, and for this we'll just use a simple imputer here. And what this is going to do is imputing is just the process of filling in the missing values with something else. And so this simple imputer, what it's going to do is it's basically going to take a statistical method on it. So by default, it has the mean, right? So it has whatever the mean of that column is. So if we're on like the deadlift column and we have, like 700, 500, 300, the mean is going to be 500, right? So for missing columns, it's just going to fill in 500. And there are other imputers available here that you can see, like nearest neighbor, which we'll try out a little bit later. I think that might be better. I wanted to go over this one because it's kind of a quick one and it's easy to see. So the first thing that I want to do here is I want to just organize things a little bit. So we have the outliers being pulled down here. That's great. What I'm going to do is I'm just going to make that into a function. So I have it on my clipboard here. So I'll paste it up here somewhere. Yeah, so remove outlier. So it's pretty much doing the same thing. It's returning that data frame rather than putting it into another variable called df and then returning that, I guess. So what we'll do is we'll just call that here. We'll call it right here. The removing of the outliers is going to need to happen after we do an impute. And that is because if we do this remove outliers, if we take a look at this function, then we're already limiting anything. So we're going to be silently dropping all of the NA values anyway, which defeats the whole purpose of doing the impute. For the actual imputing, what we first want to do is import it. Okay, so now we're going to make another function here. And by the way, notice that I'm starting these with underscores. That doesn't really mean anything. It's just kind of a convention in Python that just says like this. If developers see it, they recognize that like that's internal, like it's not meant to be used externally in like other files and stuff. It's just something I've kind of gotten into the habit of. So what we're doing is we're calling the simple imputer, and then so if we just hover over it, so the strategy, like I said, is defaulted to mean, which if we go down to, yeah, the parameters, they have it listed here. So they have mean, which is the average, and median, which is just like the middle value. They have a few other ones here that you can use, most frequent and constant, which I'm not going to use those. But I think that median is better strategy. Heck, we can play with both. In fact, you know what? Let's actually we'll call this strategy, and then we will, for impute, put in strategy median. Yeah, okay, Copilot. And then that way we can just switch it out there whenever we want to. So now we're going to come down here before the outlier removal, and we'll say df equals impute missing values. And then don't forget that this drop NA up here, we're not going to be using that anymore, so we'll get rid of that. And then what we want to do is I have these print statements on my clipboard. So what we're doing is we're calling the .head method on the data frame. So that says what the first couple of values are. So this will just help to show us what the impute is actually doing. So if we save that and then run make train. Okay. So you can see we've got a bunch of NaN values here, not a number of values, basically nulls. And then it's putting them in, so it's finding that for Snatch, for example, 27 is the median of, actually, I don't think these exact line up, 25 for Snatch is kind of ridiculous. But anyway, it's 27 for one of these columns. It's finding that for the median, so it's filling that in for this column here. Lastly, I just want to put in another print statement after we've removed the outliers to basically show you that after all of this, this is what we have. So our initial data set is still 420,000. And then this mapping here, this isn't actually dropping anything. This is just mapping everything in gender to either a 1 or a 0. So we're imputing on all 420,000 of those, which is why you have to keep performance in mind. And then removing the outliers will still remove a fair amount, but I'll save that and then just run that. Okay, so clean data set now contains 13,000 athletes. So that is, if you remember before, we had it running on 1,000 athletes. Now, taking a look at the actual performance of the model, it is a lot worse than it was previously, but we have a lot more data that we're using for it now, rather than just a small subset, which is what we had before. So we need to go back to kind of strategizing on this, but I think this data impute method that we're using here is, I think it's a good trade-off for us to have ultimately. Anyway, that is what I wanted to show you in this one, so thanks for watching, and I will see you in the next one.